Ever stumbled upon something like really intriguing and you just think, I got to dive into this?
Oh, yeah, totally.
That's us today with surreal numbers.
Okay, I'm intrigued.
Mind-bending math. But before you think about changing that dial,
Please don't.
this is not a lecture or anything like that.
Not even close. We're talking about exploring a fascinating world, and not just any world, but through a story.
Yeah.
Which, honestly, who doesn't love a good story?
Right. A story is way more fun than just, equations and stuff.
Oh, yeah, absolutely.
We're diving deep into excerpts from Surreal Numbers, how two ex-students turned on to pure mathematics and found total happiness.
Wow.
By Donald Knuth.
Okay.
Well, I mean, the title alone.
Yeah, it grabs you.
And the way Knuth writes this, it's like a mathematical adventure novel.
Yeah.
It's pure genius.
It really does make you feel like you're part of the discovery, don't you think?
Absolutely.
Yeah.
So picture this. You're on this secluded beach. The sun is warm. You hear the waves crashing. And all of a sudden, you find this ancient stone tablet.
Huh?
And it's covered in these cryptic mathematical symbols.
Oh, wow.
That's the scene Knuth sets.
Sounds like the beginning of a classic adventure.
It really does, and it's a mathematical one for sure. We're talking number theory here.
Okay.
But trust me, this is anything but boring.
All right.
We're deciphering this mystery right alongside our protagonists, Bill and Alice.
Bill and Alice.
Yeah, they're former students who decided to ditch the daily grind, trade those spreadsheets for seashells, They're on this remote island trying to find themselves.
I can get behind that. Finding themselves and stumbling upon ancient mathematical mysteries.
Exactly. And little did they know they'd stumble upon a whole new way of looking at numbers thanks to this guy, J.H.W.H. Conway. Talk about leaving your mark on the world, right?
Having your name etched on a stone tablet that holds the secrets to like a new number system, that definitely beats a Post-it note.
You got that right.
Yeah.
But okay, let's not get ahead of ourselves. Let's hear what Bill, our eager translator here, what he uncovers, right?
Right, lay it on me.
So this inscription starts off, get this, like something straight out of Genesis. In the beginning, everything was void, and J.H.W.H. Conway began to create numbers.
Whoa.
Come on, that's epic.
It's like setting the stage for something big.
Oh, it definitely delivers. It goes on. Conway said, "Let there be two rules which bring forth all numbers large and small. This shall be the first rule. Every number corresponds to two sets of previously created numbers, such that no member of the left set is greater than or equal to any member of the right set." Now remember that. No member of the left set is greater than or equal to any member of the right set. That's crucial.
Got it. Sounds simple enough, but I can already feel my brain starting to, work a little bit.
Just wait, there's more.
Yeah.
And the second rule shall be this. One number is less than or equal to another number if and only if no member of the first number's left set is greater than or equal to the second number, and no member of the second number's right set is less than or equal to the first number.
Okay, I'm not gonna lie, that one's a mouthful.
I did warn you, it gets wild.
Yeah.
But here's the real kicker, right as we're getting to the good part. How these rules create that first number from the void left set and the void right set, called 0, it breaks off. The inscription just ends.
Are you kidding me? They went all the way to this deserted island, they find this cryptic mathematical tablet, and they don't even get the complete message.
I know. It's like enough to make you want to organize an archaeological dig yourself.
And
But don't worry.
Luckily for Bill and Alice and us, Alice has a breakthrough.
Okay, all right. I need to know, what is it? Okay, so what's the big breakthrough? What's Alice discover?
Well, she realizes that, yeah, the language on the stone tablet, it's ancient, but the ideas behind it, there's something that they can totally understand with a little modern-day mathematical know-how. Ah, so they're bringing in the big guns, huh? Using those mathematical symbols we all know and love. It's amazing how a few symbols can unlock a whole other level of understanding,
It's like you're trying to solve a jigsaw puzzle in the dark, and then suddenly, boom, someone flips the switch, lights are on, you can see everything.
Exactly.
And that's kind of what happens here. Alice starts breaking down Conway's first rule, the one about those left and right sets.
Okay.
Imagine, you have two containers, right?
Okay, got my containers. One for the left set, one for the right set.
Perfect. Now, each number in Conway's system, it's represented by a pair of these sets.
Okay.
But, and here's the catch, no number in that left container, it can't be bigger than or even equal to any number in your right container.
So all about keeping things in order, but with these sets instead of just numbers on a line.
Exactly. Now think about what this means for actually creating numbers. Each new number needs previously created numbers to kind of define it, right?
Right.
But if we're talking about the very beginning, the very start, where do those initial numbers even come from?
It's like the chicken or the egg. How can you create something from nothing?
And that is where Conway, he throws a curveball, or should I say an empty set.
The empty set. Wait, you mean absolutely nothing, like a blank slate?
You got it. And it's denoted by that symbol, the 0 with a line through it, A, this nothingness. It becomes the foundation of the entire system. Think of it like the Big Bang of Conway's number universe.
Yeah.
And from this void, 0 is born.
Hold on. How do we get 0, something from nothing?
Remember the containers we were talking about?
Yeah.
0. In Conway's system, it's represented by 2 empty sets. It's written as A.
Okay, so 0 is basically defined by the absence of any other numbers. Huh, that's kind of elegant when you think about it. But how do we get to other numbers from there then?
Well, on day 2 of this whole mathematical creation story, things get really interesting. We see the emergence of math for 1 and 1.
Okay, now I'm really interested. How do you pull max 1 and 1 out of thin air? Or out of empty sets, I guess I should say.
Think back to our containers.
Okay.
To get madish 1, you have an empty left container, and then you put 0 in your right container. So it's represented as A.
So magic 1, it's essentially defined as being less than 0 because its left container has nothing in it. Well, that right container, it has that 0.
You got it. And for 1, you just flip it, put 0 in the left container, and keep the right container empty. So that's all about their relationship to 0 and to each other.
Wow, so from emptiness springs forth a whole number line. But weren't Bill and Alice struggling with, how to even write all of this down?
You're totally right, they were. But just as they're grappling with these concepts, Alice notices something. There are these additional carvings on the stone tablet. Symbols.
No way.
And guess what?
What?
They perfectly match the notation they've been working with.
You're kidding. It's like the universe just handed them the answer key or something.
Right. But you know what they say? With great discoveries always come even bigger questions.
I bet. And I bet they have a ton of them. They've only just started to scratch the surface of Conway's world.
Okay, so I've got day 1, we've got day 2 of Conway's number creation, kind of building this whole thing up, but it's getting a little too quiet for me now. What's next in this mathematical mystery we've got going on here?
Well, on day 3, it's not so much about new numbers just kind of popping into existence. It's more about, I guess, really understanding the rules of the game, right? Like Bill and Alice, they get to this section, and Conway starts proving these things that just seem, I don't know, kind of obvious.
Yeah, 0 is less than or equal to 0. I think I'd be wondering if we'd hit a dead end, too, if I was them at this point.
Right. But the thing is, before you can start bending the rules, you got to figure out what the rules actually are in the first place. It's like Conway is meticulously, very carefully, setting the stage for his new number system, basically making sure that every relationship between these surreal numbers, it just makes sense.
So less about the what and more about the why at this point, really laying down the law of the land, so to speak.
Exactly. And you know what's really interesting is that this leads to a big question that Bill really starts to wrestle with, which is, what does equal even mean when we're talking about these numbers, these surreal numbers? Because it's not as simple as just two things being the same. It's more about them having this kind of likeness based on how they relate to all the other numbers in the system.
Okay, now that is a brain teaser for sure.
Right.
So how do they even begin to unravel this whole likeness thing in this surreal number world?
Well, they take a page from Conway's playbook and use that second rule, the one about, comparing numbers using those left and right sets. But get this, instead of trying to prove that two numbers are alike, they do the opposite. They try to prove that two numbers are not alike.
So a little reverse psychology for these surreal numbers. I kind of like it.
Exactly. And you know what? Through this process of trying to prove what something isn't, they start to unlock this whole other concept, the concept of positive numbers within Conway's system. That's when they realize that positive numbers are those that are greater than or like zero. Zero, it's at the central point in their numerical universe. Everything revolves around it.
0, you sneaky devil. You've been running the show this whole time. But I got to ask, because it seems like with each new number, this whole system, it just gets bigger, more complex. How do they even keep up at this point?
That's where Alice's intuition comes in, because she has this hunch that there has to be some kind of pattern, a shortcut to help them navigate this ever-expanding world of numbers. And wouldn't you know it, she stumbles upon a principle that honestly a lot of us probably take for granted. It's called the transitive property.
Okay, the transitive property, refresh my memory. What is that again?
So basically, it just means that if you know x is less than or equal to y and y is less than or equal to z, then x must also be less or equal to z. Like a chain reaction, but for order, I guess you could say.
Okay, yeah, no, that does sound pretty straightforward when you put it like that.
Right. But in the world of Conway's system, this simple idea, it's a total game changer. And the way she figures it out is pretty amazing. Instead of trying to prove that it's true directly, she tries to find an example where it doesn't work. And guess what?
She can't find one.
Exactly. She can't find a single instance where that transitive property breaks down within Conway's rules. So in that moment, that aha moment, she proves this fundamental truth about these very strange and surreal numbers.
So by trying to disprove it, she ends up proving it. Talk about a plot twist. But, this whole deep dive, it really gets you thinking, what other secrets are hidden within Conway's system? What about day 4, day 5, day 100? Does it ever stop?
Yeah.
Did Conway himself even figure out all the answers?
Those are questions for another deep dive, my friend.
That's right.
But I think, for now, let's just take a moment to really appreciate what we've learned. How a simple story, like the one we just dove into, can unlock these really profound mathematical concepts. Because even in that abstract world of numbers, there's always something new to discover, right?
Couldn't have said it better myself. From that void to zero to this whole new way of understanding numbers, Conway's Surreal Numbers has certainly taken us on a journey today.
They really have.
And we hope you've enjoyed this deep dive as much as we have. Until next time, keep those brains buzzing.